So now we had learned that they were electrons, and electrons were occupying the negative charge of the electron was spread or distributed in certain places around the nucleus. So if it was distributed in a spherical region around the nucleus, that was an s orbital. It could be distributed in two lobes around the nucleus. That would be a p orbital, and there were three types of p orbitals: px, py, and pz, depending on the orientation. And then you had d orbitals and f orbitals, which I mean, the knowledge of a d orbital is not in your or the shape is in A2, so you don't need to learn the shape of this, but this is what a d orbital looks like. That if the electron is in a d orbital, then the negative charge is distributed in four regions around the nucleus. And you had an f orbital as well. So you had all these orbitals, different shaped orbitals, which were your s, p, d, and f orbitals. If you combine these degenerate orbitals or the same type of orbitals, that's known as a subshell. So if you combine the px, py, and pz, and you start talking about them together collectively, this is known as a p subshell. A d subshell is when you talk about the 5 d orbitals together. F subshell, there's 7 different types of f orbitals. We saw the diagram in the last class, but the knowledge of the shape of the f orbital is not in your course. And each orbital can have a maximum of 2 electrons. And I told you that the electrons need to have opposite spins. There's another representation, which is a box representation, where the opposite spins in an orbital are shown by 2 arrows in opposite direction. First one upward, the second one downward. Opposite spin meant that they had opposite magnetic fields. Every electron has a negative charge. The negative charge, it repels. So it's very hard for the 2 electrons and the negative charge to be in the same space or same region or same orbital. To minimize the repulsion, the 2 electrons also have a corresponding magnetic field. And the magnetic field needs to be opposite. Like if one of them has a magnetic field that shows a north, the other one has a magnetic field that shows a south, so that the magnetic fields, they kind of attract each other. So the force of repulsion, because of the negative charge, gets cancelled out by the force of attraction that is there because of the magnetic field of the electron. So all elementary particles, they act as tiny magnets. They all have a certain magnetic field associated with them. And to be in the same orbital, the electrons need to have opposite spins. Then we talked about shells, and I told you that shell is nothing physical. It just represents the energy level of the electron. So what that means is that if the electron is very energetic, it would be in a higher shell number. If it's less energetic, it would have a lower shell number. So you would have different types of s orbitals. You would have a 2s, 3s, 4s. That just means that the energy level is different. If the electron is in a higher energy S subshell, that means the electron is very energetic and it would be much further away from the nucleus. If the electron is in a lower energy subshell, then that means the electron doesn't have a lot of energy, and the electron and its negative charge would be very, very close to the nucleus. So this is what the shell represents. It represents the energy level, or if you want to figure out what the physical manifestation would be, that the electron would be further and further away from the nucleus if the energy level is higher. And then we learned that we figured out these 3 things, and we learned how do we write the electronic configuration. And I told you that every time it's almost the same pattern. Every atom follows the same pattern, which is that you can draw this table and draw diagonal arrows, and the electrons are filled according to these diagonal arrows. You keep following the diagonal arrows downwards, and that's how electrons are filled in an atom. So it's 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and 5s, and so on. And until you run out of electrons. So I'll just do a couple of electronic configurations quickly. So for example, if I have iron, it's got 26 electrons. So iron's electronic configuration would be, if I start following the arrow, the first arrow, it's 1s, and that's 1s2. Uske baad there is 2s, so that's 2s2, and then you have after that it's 2p. That would be, p is going to have 6. And remember, these are subshells. So the p subshell can accommodate, where's the subshell? So these subshells, according to the number of orbitals that they have, they can accommodate a certain number of electrons. So the S subshell can have a maximum of just 2 electrons. The P subshell, because each orbital can have a maximum of 2 electrons, so a total of 6 electrons in the P subshell. Similarly, if you talk about the D subshell, that it can accommodate a maximum of 10 electrons. And if you talk about an F subshell, it can accommodate a maximum of 14 electrons, because each orbital will have 2 electrons. So this Aufbau principle is following I mean, it's the representation of subshells. So it's 1s2, 2s2, then it's 2p6, and then it's going to be what comes after 2p, it's going to be 3s. Then it's going to be after 3s, it's going to be 3p, then 4s. 3p would be 6, 4s would be 2, and this is 20 electrons. So at the end, you'll be left with 3d, and there would be 6 electrons in the 3d. And I told you that once you write down the electronic configuration, make sure you correct the order. The fourth shell should be on the outside. It is a higher energy subshell, so it must be further away from the nucleus. Group the third shell subshells together. Group all of them together. Don't change the electronic configuration, just reorder them. Okay, so they're always ordered according to their shell number. So 1s, then you have 2s, then you have the third shell, and then you have the fourth shell. So you follow this and just rearrange them or order them properly if they are out of order. If the 4s is coming first, put it on the outside. So that's how you're going to order these. The first shell is the smallest. It can have just 2 electrons. The second shell is slightly bigger. It can have 8 electrons, because the P is going to have 6 and the S will have 2. The third shell is even bigger. It can have a maximum of 32 electrons. That's 18 electrons. That's 10 plus 6 plus 2. And then the fourth shell is going to be even bigger, and that's going to have a maximum of 32 electrons. It's 14 plus 10 plus 6 plus 2. Yes.
So what is the Aufbau principle?
The Aufbau principle is just this table. ये जो order नहीं है?
Yeah.
ठीक है, that's known as the Aufbau principle.
Okay.
That every atom follows this specific order, I mean, which you get from the table. ठीक है, is this clear? Achha, so every atom is going to have the exact same electronic configuration. So I'll draw sodium. Sodium would follow the same electronic configuration. It's going to be 1s2, 11 electrons, 2s2. Then it's going to be 2p, that would have 6 electrons. And then there's going to be 3s, which will have just 1 electron. So that is sodium. And I'm going to draw and visualize one of the atoms, although the electrons are all in orbitals, so they're kind of mixed up, but we can kind of draw what a sodium atom would look like. So sodium, starting with the first one, sodium has just 2 electrons in an s orbital, and that s orbital is a low energy s orbital. It's the lowest energy s orbital because it belongs to shell number 1. So that means there's a spherical region, and there would be 2 electrons in that spherical region over here. So yahan pe na, I'll just shade it. There would be a negative charge of 2 electrons sticking to this positive nucleus and very close to the nucleus, because the electrons are not very energetic. Then you have 2s, and it also has 2 electrons. So now the 2s is slightly more energetic. It's also spherical, so the electrons are located in the spherical region around the nucleus. So another 2 electrons, which are slightly more energetic, their negative charge is going to be distributed in a much bigger spherical region around the nucleus. Remember, these orbitals are overlapping. So the first 2 electrons, they're very close to the nucleus. The next 2 electrons are slightly further away from the slightly further away from the nucleus. The negative charge is located slightly further away from the nucleus. So then you have, after that, you have the 2p6. Now, when it comes to 2p6, it's going to be x, then you have the y, and then you have the z-axis. So here's your z-axis. So 6 electrons in the 2p. So that means the negative charge of, now p is, so there would be a negative charge that would be distributed around or on the x-axis. That is what a p orbital looks like. Then you would have another negative charge that would be distributed on the z-axis. It was other guess, so I'll just so there would be another negative charge that would be located on the y-axis, and then finally there's going to be another negative charge that would be distributed on the z-axis. So 6 electrons and the negative charge. It's x, y, and z-axis. So that is 2p6. And then finally you have another electron, and that's 3s. Now this 3s is the most energetic electron, but it's the electron, the negative charge is distributed in a spherical orbital 3s. So there's one electron, and this electron is very energetic. So its negative charge, so the negative charge of this one electron is distributed in a spherical region, and the electron is very energetic, so it would be really on the outside. So its negative charge is distributed on the outside in a spherical region around the nucleus. So this is what an atom actually looks like. Okay, it's 1s2, 2s2, 2p6, and 3s1. So 1s. So there's this tiny region around the nucleus where 2 electrons and the negative charge is all sticking to the nucleus. Then there's a 2s. So there's a much bigger, this green colored shaded area, and there are 2 electrons and the negative charge is distributed around the nucleus, sticking to the nucleus. Then you have the 2p6, which means that you have the 2p is comprised or made up of 3 orbitals, which are x, y, and z, px, py, and z. So there would be 2 electrons and the negative charge distributed on the y-axis, 2 electrons, the negative charge distributed on the x-axis, 2 electrons, the negative charge distributed on the z-axis. And at the end, you have this 1 electron, and this 1 electron is located in a very high energy 3s orbital, which is a spherical orbital, and the electron is really energetic, so it would be very far away from the nucleus. So this electron would be really, really far away from the nucleus. And if sodium were to lose an electron, it's probably going to be this one because it's so far away. I mean, sodium, everyone knows that it loses its outer shell electron. So sodium would end up losing its outer electron because it's very far away and it's very energetic. So some other atom might grab this or pull this electron towards itself. The negative charge would get pulled away from the nucleus, like by some other atom, like chlorine, forming an ionic compound. But bonding, we'll leave that to another time. So at the moment, this is how you're going to visualize atoms. Achha, ye clear? Is this part clear so far? This is clear, Alicia. So there's this clear, Rizwan.
Yes, sir.
Yes, sir.
Achha, now, so this is how atoms look like. So they've got all these orbitals, each stacked on top of one another, right? So there's an inner orbital, then there's outer orbitals which are more energetic, then there's even more energetic electrons around the atom. But they would kind of look like this. They would kind of, so you can roughly describe them as p orbitals or s orbitals or d orbitals. So this is how the electron and the negative charge is distributed around the atom. Now, the next thing is, now you can write down electronic configuration of all atoms by just following this rule. It's just follow this, and you just at the end of the day just reorder them. That's it. So I'll probably do one last one. Let's say one with the bigger electronic configuration. Let's say bromine, that's 35 electrons. So So I'll just do bromine 35 electrons. So that's 1s2, 2s2, 2p6, and then you have 3s2, 3p6, and it's 4s2, then 4p6. TK, we're following the arrows. What comes out of after 4p? That's 5s2, and I have no idea. I've lost track of the number of electrons. So I think Nibelke, I've actually messed it up. It's after 4s. There is, I didn't follow the arrows. It's actually 3d10. So need to correct this just a second. So let me just check. It's 3p6, 4s2, then 3d10, then it's 4p. And let's see how many electrons, and then it's 5s. So let me count the number of electrons up till this point. So up till this point, I think it's 20 electrons. So that is 30 electrons. So at the end, you're left with 5 electrons. So it's going to be 4p, 5. So just the same, just keep following the same thing, and you get the electronic configuration of bromine, and it tells you which electrons are in which subshell and how much energy do they have. Would they be close to the nucleus, or would they be far away from the nucleus? The only thing you have to do is reorder. TK, just make sure that the 3D, so the 3D and the 4s, group the 4s together, fourth shell orbitals, subshells together, and the third shell orbitals together. TK, just reorder at the end if the order is messed up. Otherwise, I don't think they would cut
Sir?
it. हाँ जी,
सर ये ऑर्डर में करने को ऑफ ऑफ प्रिंसिपल कहते हैं ना,
क्या कहते हैं?
जो मतलब डायगोनल कटिंग्स है इसे हम ऑफ ऑफ प्रिंसिपल कहते हैं ना.
हाँ, ये जो टेबल है ना, इसका नाम ऑफ ऑफ प्रिंसिपल है.
ओके.
ठीक है. अच्छा, मूविंग ऑन. अच्छा, मूविंग ऑन. दो तीन छोटी मोटी चीजें. ठीक है. देयर आर कि हाउ आर इलेक्ट्रॉन्स ऑक्यूपाइंग अ सबशेल. ठीक है. We learned how to write the electronic configuration. So the question is, how do electrons fill a subshell? Now, it doesn't matter for an S subshell क्योंकि वो तो होता ही एक है. So how do electrons fill a subshell? So it doesn't really apply to an S subshell. But when it starts, what about P subshell? So how would a P subshell fill up? So remember, a P subshell is made up of 3 orbitals. One is the px, you have a py orbital, and you have a pz orbital. So a maximum of 6 electrons can occupy this P subshell. So let me draw a P subshell. Electron would be on the x-axis, y-axis, and it might be on the z-axis, which is your pz orbital, and the nucleus is in the center. So maximum electrons would be 6. Now, if the maximum number of electrons is 6, so what if the P subshell has just 1 electron? So where would that go? That 1 electron conventionally would go into an px orbital. That 1 electron and its negative charge would be distributed on the x-axis. You can draw the lobes, just showing that the electron is located on the x-axis, and it's distributed on the x-axis. So that is P1. A P subshell having just 1 electron. Now remember, in 3-dimensional space, no one has written these letters. I mean, look at the 3-dimensional space that's around you. There is no x-axis, there is no y-axis, there is no z-axis. Remember, these are made up axes. I mean, you just put an axis, like if 90 degrees to it, you put another axis, 90 degrees to both of them, that's the z-axis. But in reality, the letters are not written anywhere. So it's up to you. I mean, whichever you choose, I mean, it's up to you. It's an arbitrary decision. You can call any one of the axes as x, and any one could be called y, and any other axis could be called z. So the letters are just arbitrarily assigned. So which means that they're all axes are identical. Okay, you're the one who's deciding to call this one as X. You could have called this one as X. So we're just going to follow convention. The convention is you fill the X first. But remember, all three are identical. It doesn't really matter which one gets filled first. So basically what's happening is the one that you're filling first is the one that you're going to call X. So this is your px orbital. Now, if the p subshell has 2 electrons, how would the 2 electrons fill up? The first electron would go into the X. The second electron would choose to occupy an empty space, which is the py. So there were 3 orbitals, px, py, and pz. So now one would go over here and one would go over here. The reason it's not going to occupy px again is because if there's empty space available, the electron would decide to take that empty space, because px already has an electron, so there would be some repulsion. And similarly, if there are 3 electrons, then if there are 3 electrons, then the third electron would decide to go into a pz. So that basically means that electrons, they decide to occupy orbitals in a subshell in a single manner first. First, all of them would get filled by 1 electron each. Once that is done, now if you have 4 electrons in the p subshell, now the electron has no choice. It has to occupy an already half-filled orbital. So it would go into the px. Remember, 2 electrons maximum can occupy an orbital. So p4 would look like this. It's going to look like it would be px2, py1, pz1, and so on. So if you have 5 electrons in the p, then the 5th electron would decide to occupy an already full half-filled y orbital. So y orbital would now have 2 electrons. And similarly, if you have a 6th electron, the 6th electron would decide to occupy the pz orbital. And the pz would also be full, and it will have a maximum of 6 electrons. So the rule is electrons always fill a subshell in a single manner first. हाँ जी.
सर इसके अंदर आपने कुछ बताया था कि पहले एक सब शेल फिल होगा, मतलब everyone would receive 1 electron and then later they would like double up. How? I didn't understand that part.
क्या करना है?
Like if each orbital has like 1 electron, at first everyone would receive like 1 electron, then they would double up. Like how? I didn't get that.
वो है ना, इलेक्ट्रॉन्स आ रहे हैं ना, अब उसके इर्द-गिर्द इलेक्ट्रॉन्स आएंगे. ठीक है, मैंने क्या कहा था कि हर ऑर्बिटल में मैक्सिमम कितने इलेक्ट्रॉन्स होते हैं? मतलब जितने भी ऑर्बिटल्स हमने पढ़े थे, मैंने क्या कहा था कि हर
2
ऑर्बिटल
electrons.
2 इलेक्ट्रॉन्स होते हैं ना. तो हमने ये पढ़ा था कि पी सबशेल आइडेंटिकल होता है ना. ठीक है, तो मैक्सिमम कितने इलेक्ट्रॉन इसमें आ सकते हैं? 6 आ सकते हैं ना. 2 इलेक्ट्रॉन इधर, 2 इलेक्ट्रॉन इधर, 2 इलेक्ट्रॉन इस तरह. ठीक है, ये क्लियर है कि हर ऑर्बिटल में मैक्सिमम 2 आते हैं ना. तो पी जो सबशेल है,
Yeah.
P subshell is made up of 3 orbitals, right? तो
Yeah.
अच्छा, तो उसका मतलब ये कि it can have a maximum of 6 electrons, right? तो point is कि जरूरी नहीं कि 6 इलेक्ट्रॉन हो उसके पास कम भी तो हो सकते हैं. उसके पास it could have any number of electrons, right? 6 भी हो सकते हैं, 6 से कम भी हो सकते हैं. It could have 3 electrons. ठीक है, 3 electrons अगर होंगे, अगर है ही 3 electrons, तो मुझे बताओ कि पी जो सबशेल है वो किस तरह फेल होगा? उसमें सारों में एक एक जाएगा ना, क्योंकि बहुत सारे एटम्स होते हैं जिसके अंदर पी के अंदर होती ही 3 इलेक्ट्रॉन्स है. तब 3 इलेक्ट्रॉन्स होंगे तो एक इलेक्ट्रॉन इधर चला गया, तो दूसरा इलेक्ट्रॉन इधर क्यों आएगा? मतलब उसको खाली जगह मिली हुई है तो उधर चला जाएगा. और फिर तीसरा इलेक्ट्रॉन होगा, उसको खाली जगह मिली हुई है तो उधर चला जाएगा. ठीक है, भरने कितने इसमें? मैक्सिमम 6 भरने हैं ना. तो मैं तो वो कह रहा हूँ कि अगर तो 6 फिल करने हैं तो 6 तो सारा का सारा फिल हो जाएगा. ठीक है, लेकिन व्हाट इफ यू हैड टू फिल लेस देन 6? तो वो किस ऑर्बिटल में कितने इलेक्ट्रॉन्स जाएंगे? अगर 3 होंगे तो 2 इलेक्ट्रॉन इधर चले गए, 2 इलेक्ट्रॉन एक इलेक्ट्रॉन इधर चला गया, एक इलेक्ट्रॉन वो खाली जगह पड़ी है वहां चला जाएगा, एक इलेक्ट्रॉन इधर चला जाएगा। अगर आपके पास पी में 4 इलेक्ट्रॉन्स पड़े हुए हैं तो 4 इलेक्ट्रॉन्स किस तरह फिल अप हुए होंगे कि पहले एक एक सारों में चला गया, फिर इनमें से एक में ना 2 चले जाएंगे। जिस तरह इफ रिमेंबर इलेक्ट्रॉनिक कॉन्फ़िगरेशन तो आप ऑफ ऑफ प्रिंसिपल से देख रहे हो ना, वो जो टेबल है कि इफ आई हैव सल्फर, sulfur is 16, so if you write down the electronic configuration of sulfur, it would come out to be 1s2, 2s2, 2p6, 3s2 and 3p4 आ रहा है एंड में। यहाँ पे मसला है ना, व्हाट डज 3p4 लुक लाइक? 3p अगर फुल होता है उसका मतलब होता है ये सारे फुल हैं। अगर सल्फर में यू जस्ट हैव 4 इलेक्ट्रॉन्स, तो हाउ वुड द 4 इलेक्ट्रॉन्स ऑक्यूपाई दीज 3 ऑर्बिटल्स? रिजवान समझ आ रही है बात?
यस सर।
तो 4 इलेक्ट्रॉन्स किस तरह होंगे कि पहले तो सारों में एक एक जाएगा, फिर चौथा इलेक्ट्रॉन इनमें से एक में ना डबल हो जाएंगे। ठीक है,
यस।
मतलब जो बेसिकली आप समझ रहे हैं ना वो ये समझ रहे हैं कि अगर 3p4 लिखा हुआ है ना, तो ऑर्बिटल वाइज व्हाट डज दैट मीन? क्योंकि बहुत सारी अरेंजमेंट्स हो सकती हैं। 3p has 3 orbitals, 3px, 3py and 3pz। सो इनमें दो दो हो सकते हैं, उसमें ये खाली हो सकता है, ये भी एक ऑप्शन है ना। ठीक है, या हो सकता है कि सारों में एक एक हो और फिर पहले वाले में 2 हो जाए। तो व्हाट आई एम सेइंग इज कि दिस इज द राइट वन, कि पहले सारे एक एक फिल होंगे, उसके बाद चौथा इलेक्ट्रॉन जो है ना वो फिर किसी एक में जाएगा। ठीक है, समझ आइए बात?
यस सर।
तो अगर 6 इलेक्ट्रॉन्स डालने फिर तो देयर इज नो इशू, 2 इलेक्ट्रॉन्स है, 2 इलेक्ट्रॉन्स है, 2 इलेक्ट्रॉन्स है। बट इफ देयर इज लेस देन 6, तो देन there's an issue, like where would the electrons go? और इसी तरह अगर नाइट्रोजन है, नाइट्रोजन has a total of 7 electrons. So in that case, it means that you've got 1s2 and you've got 2s2 and you've got 2p3. तो that means कि जो 2p सबशेल है ना वो उसमें फुल ही नहीं हुआ, जस्ट 3 इलेक्ट्रॉन्स है। So that means कि it will have 3 orbitals, 2px, 2py and अब 3 इलेक्ट्रॉन्स की इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या होगी if there are 3 electrons going into this? One इधर, one इधर, one इधर। ठीक है, that's how 2p3 would look like। ठीक है, is this clear?
यस सर।
अच्छा, अब ये कि हाउ डू इलेक्ट्रॉन्स फिल इन द सबशेल? ठीक है, फिगर दैट आउट। अच्छा, फिर there's a box rotation. A lot of times they tell you to fill boxes. Same thing, exactly same thing, whatever we're doing. So now when it comes to box notation, it's going to be okay, I'll pick an atom. Okay, let's say I pick oxygen. Oxygen has 8 electrons. 8 electrons would be 1s2, 2s2, और फिर 4 बच गए, तो 2p is going to be 4, यानी इसका मतलब 2p is not full. Box notation is okay, they would just 1s subshell is, I mean, it's got one orbital box. ठीक है, then you have a 2s, that's another box. But 2p is made up of 3 orbitals. So that basically means there would be 3. So there's going to be 3 boxes. So that is how it's going to look like in a box representation, which is exactly the same. ये 1s है, this represents 2s, this represents 2p. So 2p के अंदर there are 3 orbitals. So 1s is 2 electrons, so that's one arrow downwards, opposite spins, 2 electrons. 2s is going to have 2 electrons, one arrow up, one arrow down. ये ऊपर और नीचे का मैंने बताया था कि they would have opposite magnetic fields, ताकि वो they're able to attract each other. अच्छा, 2p4 किस तरह होगा? पहले तो सारों में एक एक, I mean this is 2px, this is 2py and this one is 2pz. So सारों में एक एक इलेक्ट्रॉन जाएगा और फोर्थ इलेक्ट्रॉन फिर एक में जाके डबल हो जाएगा। So this is the box representation, okay, which represents the same thing. Okay, every box, each box represents an orbital. It represents an orbital. यानी ये जो 2p है ना, that's a complete subshell. 2px, 2py, 2p. So it's basically 3 boxes. So a lot of times, instead of just writing the electronic configuration, they also give you boxes. And these boxes could be arranged according to the energy level as well. For example, if I were to write for oxygen, the oxygen तो हो चुका है. Let's pick another atom. Let's say I want to talk about.
सर
हाँ जी.
सर ये बॉक्सेस थोड़े से सेपरेट हुए 1s2 2s2 ये इसी तरीके से लेकर जाते हैं.
हाँ ठीक है, वो 2p आइडेंटिकल है ना, वो बिल्कुल 2p इज आइडेंटिकल. तो 2px 2py 2pz उनकी बस ओरिएंटेशन डिफरेंट है. सो they're all together. ठीक है. अच्छा, अब ये कि फ्लोरीन का कर लेते हैं. Okay, I've got 1s2 2s2 get 2p6 9 electrons है ना, नहीं 2p5 बस खत्म. 2p5 तक है, बल्कि क्लोरीन कर लेते हैं. बॉक्सेस बनाने ही थोड़े ज्यादा बना लेते हैं. सो लेट्स गेट रिड ऑफ फ्लोरीन. Chlorine is going to be 17. So 2p6 17 electrons. 2p6 3s2.
सर
हाँ जी.
सर जब आप एक्सप्लेन कर रहे थे थोड़ा सा कनेक्शन का मसला आ गया था. आपने कहा था कि ओरिएंटेशन डिफरेंट होगी इसलिए बॉक्सेस डिफरेंट होंगे.
नहीं, उसमें मैंने कहा था कि ये बॉक्सेस इकट्ठे क्यों हैं, क्योंकि सेम सबशेल है ना,
या
उसमें 3 ऑर्बिटल्स आ जाते हैं ना, px py और pz. एस सबशेल में एक ही
जी
ऑर्बिटल आता है ना, तो इसलिए वो एक ही होगा.
या
ठीक है.
ओके ओके सर ओके सर.
चलो, उसी तरह ये बॉक्सेस कभी वर्टिकल एनर्जी के साथ ना उन्होंने शो किए होते हैं. ठीक है. सो एनर्जी, देयर इज एन एनर्जी एक्सेस and they write them vertically इस तरह के. 1s is the lowest energy, so that box is going to be at the bottom. ठीक है. अच्छा, फिर उसके बाद कौन सा होगा? 2s slightly higher energy. ठीक है, इसको सही कर लें. अच्छा, फिर 2s के बाद there's going to be 2p6. तो एक और बॉक्स बीच में. अच्छा, that's 2p6. फिर cs आ जाएगा. And after 3 there's another 3p. ठीक है. तो 3p के अंदर फिर से you have how many boxes? ज्यादा हो गए, कम. This is fine. ठीक है. So sometimes they show it energy level wise. ठीक है. So you have, so I'm just going to fill them up. It's going to be 1s 2. ठीक है. They won't label it, वो खुद ही label. This is 2s2. Greater energy. Then after 2s2 there's 2p6. So that's, first they get filled in a single manner and then they start pairing up. Then there is 3s2. And after that there is 3p5. So pehle the first they get filled in a single manner first, and then they start getting paired up. Okay, only 5. So the last one is not paired. So sometimes they show it energy level wise as well. ठीक है. Is this clear?
सर
हाँ जी.
सर इस टाइप के क्वेश्चंस आएंगे जिसमें एनर्जी लेवल्स को डिस्कस लाइक एक्सप्लेन या लिखा होगा
हाँ वो तो
उन्होंने.
हाँ हाँ, इसलिए तो बना रहे हैं. ठीक है. अच्छा, फिर उसके बाद there are 2 special cases that you have to remember. कि they're not just 2. Remember the offer principle. ठीक है. You have this principle कि every atom has to be filled in this way. ठीक है. But remember there are some exceptions. छोटी मोटी exceptions. ठीक है. They don't follow the offer principle completely. मतलब 90% वो follow करोगे, बीच में कहीं ना कहीं एक आध मसला होगा. ठीक है. So the electronic configuration would come out to be slightly different compared to the off-bow principle. So wo jo there are two special cases which you got to remember. Okay, so those two special cases, because they are common as well. Remember, they're more than two, but since they're not common, so we're not going to talk about the others. Okay, so two special cases. That don't follow the off-bow principle completely. So they don't follow the table. कौन सा वाला principle है? I think this is a school principle. This one. So they don't follow it completely. And those are copper. So remember, copper has 29 electrons. So copper's electronic configuration according to the off-bow principle is 1s2, 2s2. Then it's 2p6. Then it's 3s2. 3p6. Then it's going to be 4s2. मैं पहले से उसका order ठीक कर रहा हूँ, ठीक है? 4s2. And after 4s2, there is 3d. 9. So that is 29 electrons. And that is the electronic configuration according to the off-bow principle. ठीक है? You ऊपर table देखो, it's according to the it's according to it. But the thing is, the electronic configuration would be slightly different. ठीक है? उसका जो end वाला part है ना, that's actually, instead of being 4s2 and 3d9, it's actually 3d10 and 4s1. ठीक है? So the electronic configuration at the end is just very slightly different. So you got to remember this, that according to the off-bow principle, it's 3d9 and 4s2. But according to the reality, the actual electronic configuration, it's actually, so you just have to remember this exception. इसके बारे में कहते हैं कि for copper, and this only applies to copper only. Half-filled and completely filled are more stable. So half-filled and completely filled orbitals. Sorry, subshells. So half-filled and completely filled subshells are more stable. And this thing applies to chromium as well. Chromium ka case hai ki it's 24 electrons. So according to the off-bow principle, it should be 1s2, 2s2, 2p6, and then there is 3s2, and then there is 3p6.
Sir?
हाँ जी.
सर ये जो आपने ऊपर बनाया ये कौन सी कॉन्फ़िगरेशन है और नीचे ये लाइक इनमें क्या डिफरेंस है?
नहीं, ऊपर वाली ऑफ-बोव प्रिंसिपल वो जो टेबल है उसके मुताबिक थी ना.
ओके.
जो ऊपर वाली
रियल है,
नीचे वाली असल में, तो ये स्पेशल केस है, एक्सेप्शन है, ठीक है. सो इट्स डिफरेंट. तो थोड़ा सा डिफरेंट, इंस्टेड ऑफ 3d9 4s2 इट्स एक्चुअली 3d10 and 4s1. अच्छा, इसमें भी यही है कि chromium key, you're getting this thing, but the reality is chromium actually looks like this, slightly different. Instead of 3d4 4s2, it's actually 3d5 and 4s1. So the actual electronic configuration is kind of like this. तो ऊपर वाली, I'm just going to cancel that one out. ठीक है, ये गलत है. तो so that's actually the, so remember these two special cases that don't follow the off-bow principle completely. ठीक है, ये clear है? चलिए ठीक है, we're done.
Yes sir.
अच्छा, हाँ.
So these are the only two special cases, right?
नहीं देयर आर लॉट मोर, ठीक है, लेकिन बस ये वो है जो कॉमन है, ठीक
Oh,
है। और मतलब रिमेंबर नॉट ऑल एटम्स फॉलो द ऑफ प्रिंसिपल एग्जैक्टली, मतलब मोस्ट एटम्स डू, नॉट ऑल ऑफ देम, ठीक है, स्पेशली बिग एटम्स जिनके बहुत ज्यादा इलेक्ट्रॉन्स होते हैं ना, दे डोंट एक्चुअली फॉलो द ऑफ प्रिंसिपल अ लॉट ऑफ टाइम्स, ठीक है। लेकिन आपको बस इन दो का पता होना चाहिए, ठीक है। चलिए ठीक है, लेट्स कंटिन्यू विद दिस, ठीक है, नेक्स्ट क्लास में पास पेपर्स और इसके वो कर लेंगे। Remember, it looks easy. I mean, at least the electronic configuration, but the questions in past papers can be tricky. Okay, so we'll practice those questions. So, okay, let's continue to, in the next class then. Okay, okay, everyone. Allah Hafiz.